Hi everyone, and welcome to our first real lesson video. Today we're going to be looking at how we ask and answer scientific questions. Today's note-taking title is Asking Questions and Creating Hypothesis. You'll notice you're always going to get a page like this at the beginning of every lesson, and you're going to use this information to set some Cornell notes. You'll see we have title here, Asking Scientific Questions and Creating Hypotheses. And then we always include the essential question here. How do scientists answer questions? You'll see that page number should be 4. But also we have the date underneath. And if you're taking them on Tuesday, you'd have 9:15 here. All right, and then we have a column for putting cues and questions after the note-taking. And here's where our note-taking happens. All right, so you notice I've even given you the key terms and definitions and things that we need to be looking at within these notes. This is kind of baby steps on the Cornell notes. You guys will be setting this stuff up yourself probably within a month or so. At the end of this lesson, we want to be able to distinguish or tell the difference between scientific and non-scientific questions, and be able to create a hypothesis that answers a scientific question. In order to do that, we use something called the scientific process. It is a method that helps us develop a plan to answer a specific scientific question in as clear a way as possible. All right, so this is not something you need to include in your notes. For now, it's an overview. So what is this process? The first step is to make an observation and gather information. Next, based on your observations and information, ask a question. Then, based on that question, create a hypothesis and develop an experiment to test your hypothesis. In your experiment, you're collecting data. So this next step is you want to analyze your data. You want to look and see, what does the data mean? And then finally, based on your analysis, you want to make conclusions about your hypothesis. All right, now this method was nice and linear, which means one way. All right, a straight line, starting at the top and working our way to the bottom. But in real life, the scientific process is not linear. Again, we're not including this in our notes as an overview. But you can see that we have a lot of things going on. So we make an observation, ask a question, develop our hypothesis, design our experiment. So far, that looks pretty linear. But when we get down here to actually doing the experiment, sometimes we wind up with new and interesting observations that lead us to make more hypotheses. And this can go on and on and on. And this is why science is so prolific at developing new information and new questions. We can look at our results, and sometimes our results don't support our hypothesis. In that case, we have to come up with a new hypothesis and do new experiments, and so we can go that direction. Even if our results seem to support our hypothesis, that experiment still has to be repeated by other people. All right, so your results really aren't valid unless it's been repeated. And then finally, after enough times, enough different people have run this experiment and it's accepted by the whole scientific community, maybe you're able to create a scientific theory. Okay, so we're really going to focus on this part of the scientific process for you guys right now. All right, so the first step is to make those observations. And what is an observation? If something is in red in your notes, it means that it's a vocabulary term and should be included in your notes. All right, so observation is a way to describe something using your 5 senses. So something you can smell or see or touch or taste or hear. We can also enhance these senses, right? So it doesn't just have to be us, but we can use technology to do this. We have little electronic sniffers. We have robots that can manipulate things for us. We have microscopes, so we can see things that we could never see before. And we have technology, microphones and oscilloscopes, that allow us to hear things that the human ear isn't capable of hearing now. All right, so let's look at some examples of this process in action. Let's say that you're going to make breakfast, and you want to make toast for breakfast. You put the bread in, try to press the lever, but you don't hear the clicking noise. It doesn't catch, nothing happens. All right, so your observation is, the toaster won't toast my bread. Once you know more about a topic, so we're going off to scientific questions in general here. Once you know more about a topic, you can take an observation and you can ask a scientific question. Sometimes I'm going to give you your scientific question with an assignment or a lab. Okay, so sometimes your teacher will ask you who, why, when, normally a why question. All right, so that's different from your observation. Your observation can lead to a scientific question. We have to be careful though, because there's different types of questions, right? And we only want to focus on scientific ones. Scientific questions are objective, right? So objective means something based on facts. An example of a scientific question would be, how much does a laptop weigh? Right? Because that's a question that is based in fact. I can weigh a laptop. Unscientific question is subjective. That means that this is a question that is related to feelings or opinions. Right? So if I said, what is the best type of computer? Or what is the best type of laptop? That's not scientific, because that question is asking for somebody's opinion. All right, so let's look at an example. Let's go back to our toaster. Right? The question was, or I'm sorry, the observation was, my toast won't toast. So we can develop a scientific question based on the observation. Why won't my toaster toast? We can investigate that and try to find the reason. All right, that's not opinion. All right, so here's another important definition. We're going to try to develop a tested, educated guess that answers our scientific question. This is how we formulate our experiments. That's called a hypothesis. Okay, notice that this is in red. That means this is a definition that needs to go into your notes. A great hypothesis has this format. If something, then I think, because. All right, so if is conditional. All right, so we always start it with if. Then we're going to restate the question so that we know for sure the hypothesis relates to the question. That's going to go right here after the if. Then we're going to make sure hypothesis is testable and measurable. All right, that's how we know for sure that we can get a good experiment to go with it. So then I think, and this is where you're going to make your testable and measurable prediction. And we include this part on the back that says because we need a reason. You have to show that there was a logical reason for your prediction. Now, scientists, professional scientists in the real world don't always necessarily add this because part, because their reasoning is usually stated somewhere within the experiment itself. But you guys aren't professional scientists yet, okay? So we're starting with this format to ensure you're thinking through your prediction. All right, so what does a hypothesis sound like? If our question is something like this: what'll happen to my running speed if I run 4 times a week instead of 3? And I hypothesize, or create a hypothesis as, if I run 4 times a week instead of 3, so there I restated my question, then I think I will get faster by 20 seconds every mile. That's measurable, because I will be in better physical condition. And this is a logical reason for my prediction. All right, so a hypothesis that could go with our toaster scenario might sound like this. Maybe you're thinking, and there's not just one way to do this, right? There could be lots of different hypotheses for this. But one possible one might be, oh, well, maybe the outlet is broken, right? If that's your train of thought, if that's your reasoning, we can take our question, why won't my toaster toast, and make a hypothesis that maybe sounds like this. If my toaster doesn't work, then I think it will toast if I put it into a different outlet because it's new and it was working yesterday. And the other part kind of got cut off on your screen here, but it says, so maybe the outlet is the problem. Right? So there's a logical reason why you think that the toaster will work again if you plug it into a new outlet. All right? That is a testable hypothesis. All right, that's all we have for today. Finish up your notes, and when we meet on Thursday, we're going to do some practice with science, or actually some of you will meet on Friday, with scientific questions and writing hypotheses. See you then.